Hello everyone, welcome to our course Reinforcement Learning. As part of this course, in this lecture, I will explain Python implementation to build a random agent in mountain car environment. So in the previous lecture, we discussed mountain car environment related information, like what will be the environment in the mountain car environment, what are the states, what are the actions, what are the reward, how it will work, and everything we discussed in the previous lecture. And in current lecture, we will discuss the Python implementation. So in the Python implementation, first stage is the create environment. Create environment. So how we create environment? You have to use the gym. You have to import the gym library. From the gym library, you can import the required environment. What environment you require, you can call that environment. So create environment. So for that one, first import gymnasium as gym, and environment equal to gym dot make the environment. Which environment we require? Mountain car, MOUNTAIN, mountain capital car hyphen V0. Now you can type print environment created. So once the second line executed, that means environment created. Now run this cell. The mistake here, mountain car. Yes, environment created. Mountain car V0 environment is created. Right. Now reset the environment, observe the states. Right, reset the environment, observe the states. How we observe the states? So state comma info information is equal to env dot reset. Now you got the different state informations. Now what are the different states here? You have the two types of states. First one is called as the position, and second one is called as the velocity. First one is position and second one is velocity. Okay, so that we will discuss now. Actually, the position and velocity varying between somewhere I think mentioned. Yeah. So coming to the state here, you can see the state. State has the two values. One is the car position, what is the position of the car, and what is the velocity of the car. So state in mountain car environment is represented with two discrete values. One is called as the car, two values. One is called as the car position, index is 0. Second one is called as car velocity. Car position is represented in the range of -1.2 to 0.6, whereas car velocity is represented between the -0.07 to 0.07. And these two are the two parameters which are used to mention the state of our agent. Who is the agent here? Here car is an agent. Now I want to see print state information I want to print. So in the state, first one is the first index is the car position. Car position is, what is the car position in state? Car position in state. So first index, 0th index will represent the car position, and another variable is the car velocity. So car velocity is available in the which is index of 1, with index of 1. So I want to print these two. Yeah. So the car position is -0.4 and car velocity is 0. At starting, car position -0.4 and car velocity, it is not moving, it is stable. No movement there, it is in the rest state. So car is in the rest state. So that's it. Now we will discuss about the action space. We will discuss about the action space. So I said already, those action space contains the three discrete values. 0 means left acceleration, 2 means right acceleration, 1 means no push. It is a standstill state. No acceleration, no force, no push. So it is calm. So these are the three actions. These are the three actions. Now we will get this information. How we will get this information, we will discuss now. So coming to the action space. So action equal to env dot action underscore space. Okay, so you can print that action. So this will represent a discrete of 3. That means it containing 3 values. What are the 3 values? 0, 1 and 2. 0 means left acceleration, 1 means no motion, 2 means right acceleration. You can, I hope you understand. So this is a G, that's why it is shown it as a 3. Now we will discuss how we generate the random action. Next we will discuss how we generate the random action, right? So random action, how we will generate, and how environment, that means we have a car is an agent. So how this car or agent chooses the random action, and how the environment applies this action on the agent. When this action is applied on the agent, how position of the agent will be updated, how state of the agent will be updated, not position, state, that includes both position and velocity. So now what we will discuss is how a random action will be chosen by agent, by car. Once a random action chosen by the agent, how environment applied that action to that agent. Once that action was applied, then how the state will be updated. State means how the position velocity will be updated. That we will discuss now. Then, now first see random action. So action equal to env dot action space, dot sample, run it. So it will give the random action. So what is the random action? If the action equal to 0, if action is 0, so then print accelerate left direction. So move toward the left direction, accelerate toward the left direction. Done. So if it is a 1, if it is 1, if it is 2, if it is 1, then no acceleration, no movement, no acceleration or no movement. Okay, so if it is a 2, then accelerate right direction. So you have to accelerate the car toward the right direction. So we will see how the random action will be. So accelerate right direction, that means random action is accelerate toward the right direction. Again you can run otherwise. Now again accelerate right direction, again you can run, no acceleration. If again you can run, no acceleration. If again you can run, accelerate right direction, like that. So random actions will be generated. Random action will be generated, and random action will be chosen by the car, by the agent. Okay. See, if the random action is generated, then what happened? So that whatever the action is chosen, that should be applied on the agent by the environment. So how that one will be applied? So that is how it will be applied. env environment setter, apply this action. Whatever the action is chosen by the car, that action should be applied. Once this action is applied, what it will tell? It will give the information about the next state. Once this action is applied on the agent, on the car, what will be the next state? So that will give the information about the next state, and also give the what reward it will receive. Once this action is applied, once the state is changed, so because of the change, because of that state, because of that action, what reward it will receive, that is called as the reward. Terminated, whether the algorithm is terminated. Truncated, whether the algorithm is truncated. Terminated means that means it will close, it will may fall. Truncated means maximum number of steps are reached. And finally info. Truncated represents the maximum number of steps or maximum time reached during the algorithm. Now you can print one by one, like print f next state is equal to next state. Okay. Similarly, you can print remaining all. Print reward, and you can print terminated and truncated information. That means whether it is a terminated or truncated. print the terminated and truncated information. Now run it initially. It's showing something like time limit. What I read? Yeah, maybe setup or set. I think set. In INV, already created. So we used already, right, for what's called our cart pole. Sorry, ENV step, sorry. So if you want to, if the environment want to apply the chosen action on the given agent, then you have to use step, env.step. Then it will give the information. So what is the next state? So this is the car position and this is the car velocity. What is the reward? -1. I said for every movement a reward of -1, because we will not give the reward positive, because if you give the positive reward, the car will roaming here and there and dot the more rewards, more points. That is not the goal, right? And terminated false and truncated also false. So env.step we have to use to apply the random chosen action on the agent by the environment. So if you want to, you can get the current state also. Where we got the current state? Here. We got the current state here. So our current state is nothing but the state, right? So first I will run this one. So this is your current state or initial state. Okay. Now this is the action chosen and that action is applied here. Then the next state will be coming here. So you can print current states also. Print current state equal to, what is the current state? So otherwise you can what is the current state here? Current state is mentioned by state. That means initial state. Okay, initial state. Now you can run this one. So current state is this one. Initially the position of the car is here and there is no acceleration. But after this action is applied, what action is chosen? No accelerate. No accelerate. So again the velocity is almost zero. Velocity is almost zero. No acceleration. So then this is the next state and this is the reward and this is the false. This is how we can randomly generate an action. This is how the random action is applied on the agent by the environment. Now we will discuss about the random agent creation. Now we will come with sequence. So first what we have to do, import gymnasium library as gym, create environment. So env equal to gym.make. So which environment we require? Gym.make mountain car v0. So MOUNTAI mountain car v0. Okay. Now if so this is how we can create environment. After that what we will do, reset the environment. Reset environment. Okay. Reset environment. Sorry. Done. How we reset the environment? So that is the current state or nothing but the initial state, comma info equal to env.reset. So it will provide the information about resetting the whole information. After resetting, you can print the whole current details. That means print 50. I want to write current state information. Current state information, reset environment. Done. So that's it. Now you can get the information. How we got this information? Print yes state, that current state represents the two values. One is called car position and car velocity. So car position. So that is represented with zeroth index, so it will be 0. And what is the another parameter in state? So another is called as the car velocity. In car velocity, so it is represented with index of 1. Now close this information. So resetting of environment is completed. If you want, you can run. So this is the current position and this is the car velocity. Sorry, car position and car velocity. So that's fine. Now what the next step? So we have to randomly generate the some action. Okay. So random. But thing is, this so I want to build an agent. Agent means, so for episode 1, the agent means car will choose some random action, either left or right or no movement. And environment applied the random action chosen by the car on the car itself. Once that action is applied, then the car position will be updated. Okay. For every movement, you have to give the reward of -1. Okay. So if it reaches the goal, then it got the final reward. So this process will be repeated until the number of episodes reached or until it reaches the goal. If it reaches the goal means terminated equal to true. If the terminated equal to false means it not reaches the goal, only it is moving here and there. So we have to observe that one. So episodes, how many episodes you want to train the agent? Episodes equal to, let us assume 10, and the total reward equal to 0. Now okay, total reward. Now I want to make the agent, make the car learn in mountain car environment for the 10 episodes, and I want to observe whether it reaches the goal or not. So how much a reward it is getting, that we will discuss now. So for episode in range of episodes. Now for the first step, you have to choose the random action. So action equal to env dot action space dot sample. Done. Random action will be taken. Now you can print which action is happening. So maybe you can call this one only directly. You can call this whole. Okay. So it will help you to know which action is happening in every episode. So otherwise we will leave it. We will print that action. Otherwise we will keep it, not a big issue. Okay. Done. Next step. So after action is chosen by the car, by the agent, now apply this action on the car. So then what happened? How we apply? That is called env dot I think setup env dot step, sorry, env dot step. So you have to apply the randomly generated action. Then it will give next state information, and it will give reward, and it will give terminated status, it will give truncated status, and also some information. Done. So now I want to update, I want to print. So what I want to print? Print f. So what is the episode number? Episode equal to episode plus 1. So I want to print that one, and I want to print next state. So next state means it will it contains two values. One is called as car position and car velocity. So I want to print next state. So next state equal to, so you have to pass the next state. Okay. What is the current state? That also you have to pass. So current state. What is the current state? That what initial, this one, current state, initial state, that is called current state. And later you print reward equal to reward equal to reward. Okay, reward, and terminator status, whether it reaches the goal or not. I want to print only the terminator status. terminated, that's equal to, so you have to pass this one, terminated, and keep the quote here, done. So this thing I want to print every time. I want to see what is the current episode, what is the next state, what is the current state, and what is the reward, and what is the terminator things. And also I want to what's called, I want to update the total reward, total reward is equal to total reward plus 1. Total reward equal to total reward plus 1. If truncated or terminated, if terminated or truncated, then break this one. So you can coming out of the loop, break. Okay, and otherwise the loop will be repeated. And one more thing, so you have to update the, yeah, it will break, otherwise you have to update current state, whatever the next state is, that will be taken as a current state for the next episode. That's it. Now finally you print, after a learning process you can print total rewards, print total reward is equal to, print total reward equal to total reward value, and print average reward. So average reward, AVE or AGE, average reward equal to total reward divided by, if the episode equal to 0, 1 episode, episode 1 means 2 episodes, episode 3 means 4 episodes, so I can call it as episode plus 1. So it will help you to calculate the average reward. Done. Now I want to run this code as a random agent. Now I want to see what will be the output. Yeah. So episode 1, no acceleration. So this is the next state and this is the current state. Reward equal to -1, not terminated. Similarly, no termination. Every time -1 as a reward, 10 epochs. So that total reward is -10 and average reward is 1.0, but not -10. Why what happened here? So how we calculate the total reward? So sorry, total reward equal to total reward plus reward value. Now run. Now see. So this is the episode on first episode. This is the next state. This is the previous state, and the minus reward -1. So all are false. That means never reaches the goal. And finally total reward is -10 and average reward is -1. So this is how our mountain car will learn in the mountain car environment. Car, that the agent, will learn in the mountain car environment. Over a 10 episodes, never it reaches to the goal. That's why the penalty increases to -10. Okay, so maybe I will try once again. I want to see whether it will reach. No, not reaching. Can I increase the number of episodes as 20? Then see. Number of episodes as 20. Not yet. Again, every time it is false. Okay. Can I take 100? 100. I want to make the car learn for the 100 episodes. So again, false, and total reward is -100. Because I'm not applying any particular algorithm, just randomly I am asking, take a random action for every episode. We'll see whether it reaches the goal or not. So over 100 epochs it not reaches the goal. Every time it is getting the -1 reward. So total -100 rewards are the total penalty. Okay, so hope you understand how we create a random agent in the mountain car environment. Hope you understand. And in the next lecture we will come up with some other environment. So until then, bye. Thank you.